Starting a minute or two early. I plan this to be live at 1, but I'm also testing a new platform, LinkedIn. Let's see if it's working. Either I'm going to refresh this page in 1 minute, or since I'm broadcasting, maybe there will be footage. We'll check this. And for viewers who are joining on other platforms, here is today's agenda. So we'll look into data processing in Excel using mainly VBA. We will expose methods to the ribbon, Excel ribbon. I've already done some of that work, but we will complete the missing methods. And by the end of that effort, we will fill in missing data. So I will soon check the LinkedIn situation, but let's get started. So here's a custom ribbon in Excel. Created an urban farmer ribbon. Things looked a little bit limiting here. Creating my own macros, and well, this list is now populated, but last week there was only one, this one, which used to do a lot of work for us. A lot of cleanup, copying sheets, renaming sheets, exporting stuff, creating a tab separated values file out of a comma separated values file. That's a lot of work for one macro. Also, we have a lot of missing parts here. Whether it's rain data or snow data, we need better decision making, better processes for making decisions. It's just not going to cut it to have just one macro here, one or two. This is more intentional. Let's say if I want to manipulate wind data bits, I'm only interested in these buttons, and the same goes for the rest here. We have let me close this file, and I have to first close it. Nope. And then maybe we can talk about one. So some of you may know that this CSV file, the some of the columns are also CSV, so there's like nested CSV. The value for this column is also like a CSV, so we need to expand this. So we have 5 parts here, but we're only interested in the first 2 and the last 2, and then ultimately we will clean the 2nd and the 5th here, so we will only have the 1st and the 4th after the whole operation is done. But this button is going to split the wind to necessary parts, removing that middle unnecessary part. So we have the first 2 and the last 2. Then we can do quality checks here, and when we are all done, we can say, well, I don't need this column. Done. So we'll do cleanup like this, and we will check the quality of things for many other fields here. And ultimately, where we were stuck last week was the snow part, which is this AL1. I just had to expand this to this on here. So this has a lot of missing parts. The confusion was whether there is no snow, and then the assumption was, well, it should have been marked as 0 snow instead of missing snow data. Because when there is snow, this is indicating that there is 1 centimeter of snow in the past 6 hours. So then what happens before those 6 hours? So is it 0, or has someone forgotten to write it down? So we came up with this probability calculator. So based on humidity and air temperature, we are calculating the possibility of snowfall. And we do that for temperatures above 0 and below 0. Turns out above 0 there's a sweet spot where you could have snow. So this was a big victory. There was one tiny section here that needed to be fine-tuned as far as values go, but it's just moving numbers around. However, the idea or the knowledge we gained in this area, it should be maybe implemented here and exposed to the interface. The idea is, this is what's going to happen very soon. I think that's mainly going to be the next after a few minutes of more description, I'll start this effort. I'm going to introduce a new column here, which should actually expose the possibility of snow, which should say, let's just pretend we have snow possibility or probability. We have like say false, 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 all the way false. And when we expect to have snow, or we have record for snowfall, we should actually have these marked as true. We expect to have snow, true. Only when this is true, then kind of, what's that name? Regression. So for each one of these hours, what should we have in terms of snowfall, so that after 6 hours, this is how much we have accumulated, or this is when they wrote it down. So we need to extrapolate this going backwards, right? So that's where we'll need a probability column. That's what we are going to do, and we are going to look into how we expose all this too. Just going to do a quick check for LinkedIn, and then we are starting. Hey, Mega, Asmodi, how are you? How is the situation? Waiting for broadcast. Unfortunately, I'm already broadcasting. So LinkedIn, some trouble connecting earlier, and now that I'm broadcasting, I don't think it's really capturing it. And yet here, going with the link helped. Okay, so we are live on LinkedIn. Good news. Okay. So it's okay for now. At 5 a.m. plus some missiles near. So good luck to people in Ukraine. I have at least one viewer from there, and good luck to you, sir. So I had this funny thought this morning. It's like, I guess the pandemic is over because people are back to normal bullshit. Let's fight each other because, pandemic didn't kill us. Let's just kill each other. So, unfortunate. I really wish things would look up for you. Okay, so Excel stuff. Let's go to the VBA screen. I don't know if there's another way, but this is the way I open the VBA screen. I just generally open the macros screen and I hit edit for any one of them. It takes me to this screen where I have the modules exposed. So these modules are, for example, this one is in humidity module. This is one method. Here's how they are recognized by Excel. So I don't think it's broken down by module names. There could be duplicates in modules. Maybe there is a way for it to prevent me from creating duplicates, but here, unfortunately, I cannot group them more than. It's all alphabetically listed. There is no grouping here. So kind of need to remember the function name. And when you have a lot of validators, you gotta first find validate, then name. They are not namespace in that sense. So calculate RH is here, and for which I created a custom section here, which is called a group. So in the humidity group, I'm binding the macro So that button appears here. So when I click this button or this button, this one, this is going to trigger this sub VBA world. It's a function. Well, it's not really a function. It's a subroutine. There are also functions in VBA. But for our purposes, it's doing something. So I was at that point that the other day, I think I finished. Let's see. So we need temperature, so split it. We need dew, split it. Humidity is calculated from temperature and dew, so calculate it. This is, I could have multiplied this by 100. This is 94 or 95% humidity. This is good. Now this is the base of, or the basis of this calculator, this probability, precipitation probability. So we used a slightly different version of it for really low temperatures by using a multiplier here. This is hard to read, but I think when I expose this to VBA, things are going to look much more legible. So I'm at that point to actually do the snow part. The snow is somewhat done, but it's missing that probability thing. Yes, it's coming back to me. So let's do remove redundancies to get rid of a bunch of unnecessary columns. Let's remove the rows with report type FM16. Let's get rid of those two. Waiting a bit. That part is really not necessary, but it's done. This is the column we are interested in now. I think I should first of all create a new button here, or a new function that is going to create that column for us, which is going to be snow probability. So let's go write it. Let's create a new sub. Let's say because our intention is to calculate snow probability, this should be written as if we are actually doing it, right? I'm not going to put a sub name there, like create a new column kind of thing. We will do that here. Now, by this point, we are assuming to, well, workflow wise, I am tending to go from left to right. Even in each section, I'm going from left to right. So I gotta first split the bits, say like we did it for wind here. We check the quality of things, then we clean things up, that kind of thing. Done. So we are supposed to do the same thing here too. We gotta split the snow data. So the AL1 column has now turned into snow duration and snow amount. So this much amount has snowed during this length, okay? Which is the problem case because it's kind of missing. Like, is it 0 to 0? We don't know. That's our goal today. We would ideally like to have either false or true, so we can explicitly write 0 here. So to be able to put a column here, we need to find this new column name. That's kind of how I've been doing this. It's here. And I have a very handy function here that I wrote, which is responsible for finding a column with this. So I think in another function, RH, right? Humidity. I am already doing something like, yes. So I'm finding TMP, which is temperature, and RH is calculated out of TMP and do. So I first find TMP, and yeah, let's actually kind of steal this, right? I mean, these two could be generalized, like say, add a new column to the left of something like this. We have a bunch of utility functions in a different module here. For now, let's just do this. Add a new probability column to the left of. Okay. So this is going to add a new column. We need to change this RH to snow probability. And after this operation, we are supposed to have, go here, going to remove this column. I don't even need to be here. It's going to find this column, and we'll add a new column to the left. It always does. And it's going to put a SNW underscore PRB, so which should be attached to a button. Goes calculate snow probability. We stick that under here. Done. Let's give this a better looking name. Otherwise, it takes the name from the macro, which is looking technical. Yep. Time to block some bots, but it's done. You occasionally get some funny looking URLs, very short URLs. Please don't click. They tend to go to questionable websites. So if that's your thing, do so, but fair warning. So probability, let's pick a good enough icon. This is the time when during game development you spend 5 times more effort in picking the right icon than doing the job. But it's also, I'm going to sip my coffee. So let's look at those icons. Thing like a percentage sign or a probability, like this is where we say false or true, right? It could be a dichotomy to something binary. Could just be this for now. Well, is it snowing? Is it not snowing? That sort of thing. What else? You guys are seeing a better icon, you could let me. Maybe tiny to look at, but I'll stick with that. Good enough. So here's our snow probability button. Let's click it, and it just added the probability right, like weird English, right left to the snow duration. Now we have to fill this with proper values. Now this is going to be done based on this and this. Here's a tricky question or situation. I mean, I might fall into this trap myself too. Ideally, when I get to this point, I should not have, or I should have as much cleanup done as possible. So I should not have this column. I should not have this column. And that this should be done. All this should be done, that kind of thing. The purpose of that is kind of similar like here. This is a dynamic column that I'm creating by clicking this button. which is pasting a formula here, which is to take J2 and U multiplied by some value, and again J2 added to some value. The exponential value of this is divided over similar exponential formula, except instead of du we are taking TMP, which is the H2 column, right? So out of temperature and du, via this formula we get to calculate the relative humidity. It's all good. Here's the problem though. When I wrote this, I was excited about finishing this work, this formula. I am basically assuming that this is going to be here. Normally it is not going to be here. So this formula without the I column, if this didn't exist, right, our J2 will essentially be our L2. So it's going to read the SLP values. So perhaps we should fix this logic here, because the wisdom we are going to gain here is going to help us here, because to calculate the possibility of snow we are going to depend on this and this. So we need to find the column where we have in its first row the text due, whether it's J1 or K1. We shouldn't actually know that column ID, this one. We already have some mechanism to find it for us, but this is not done in a sort of dynamic or loop context, right? This is a one shot, you find it, then you incrementally do something. Let's look at the humidity. It is deceptively simple. Left to the TMP, we add the missing column, we do it. This is where we calculate the total number of rows, which is actually now coming from a function that I wrote. So this is not going to be here either, because I improved this lookup. So that's done. But let's test it. We should have this value used in here. Let's do a close, reopen, to see. Done. Do that. We are trying to see if temperature and dew bits are separated without removing the quality columns if we want to calculate this. Yes. So the total rows lookup is working just fine. Now, okay, let's improve this. Now, something you might have already noticed when I talked about J2 or something, right? Now, the column names are different. It's as if the problem all of a sudden fixed itself. Do we really have a problem? Without changing a single line of code, how is it able to find TMP and dew and actually indeed calculate the correct values, even when we don't do any temperature or dew column lookup? Well, that's actually kind of thanks to this relative column or relative cell format. This is basically saying don't change your row reference, but in columns go and look up the third column. So this is the dew, again dew. This is the next column, which is temperature. So this 0 basically means itself. So 1 is the next column, and the third is 3 from here is dew. So that's how it kind of does its lookup, which means there's something so elegant, so simple about this, right? If you really want to be on the safe side, what is the unsafe side? Assume, like I was saying, we deleted these two columns. And these RC1 and RC3 lookups would actually give us different results, would pull the content from these columns. To remedy that, then we need to put this in a for loop to get the value of this based on some kind of like a lookup like this, which then really kills the whole elegance here, right? The cheaper way is perhaps we just say, well, we know we are going to get rid of the quality fields, right? So then from RH's point of view, temp will always be RC1 and do will always be RC2. So we could actually change this and be done with it. Okay. This is assuming we are going to have these two deleted. Okay. In fact, I'm going to delete this column too so that I can save this. I can actually do the same job here. It's now doing RC1 and 2, so this is fine. However, we still haven't answered our original problem for AL1, which is, let's split the snow parts. Let's also do this too. Are we going to follow the same trick? We're going to say, well, from this column's point of view, if we say RC minus, I don't know, 7, 8, get here or here, we could do that. It will work now, but then it will stop working as soon as we introduce more columns or we remove columns here. So that's kind of a bummer. So let's see. The reason why I'm bringing that possibility up is because during this investigation, I noticed this column too, which I had ignored previously. Turns out, this column is also about snow. Whereas this original AL1 column is about the snowfall, this is talking about the accumulation, I think. Like how much snow there is on the ground. Maybe we'll use the mix of two to come up with some kind of numbers, but I don't know. We'll see. Let me think a few more moments. Let me look here. I think I'm doing a range selection here, right? I'm selecting from the second row to the bottom row for that column, which kind of does this. Create a new column, come to the second row, select all of it, paste this formula. So that's, oops. So for all those, for that range, which looks like the whole column except the title itself. Start from cell number 2. And we say, here's your formula. let's do something simple. Necessarily stupid, but simple. I'm going to take this as a reference. I'm doing this for snow. So this is the idea, but not the implementation. So instead of having something like this, what if we had a for loop? We did something like for I equals to total rows. How do you end the for loop? Was it no, you just move the x next I. VBA is weird, man. It is weird. Speaking of weird, maybe we're curious because I'm still not sure whether the comments are spread to all platforms or not, but I think do another quick check. You're kind of seeing yourself watching LinkedIn. This is going to look recursive and meta. I think things are working. Okay, just making sure. We are still here. So we'll have something like this. This cell is naturally going to be, let's actually call this a cell, right? Or a row. Which is more meaningful. We are not selecting a range here. I think we are allowed to do this. We just want to select this cell, and that's the range. So the range doesn't have to be more than one cell. The cell itself is an acceptable range. Okay, and that is the active columns particular row number 2 at the beginning. We'll do this for all rows. So here I'm going to do something like this. So when I say, this is the part where I hate VBA. Like I'm about to type stuff, but I kind of want to move around and the syntax is not correct. So it says, what the hell? And I say, what the hell back. What happens when you find cell? Let's look at what's happening here. So we go to the top left, which used to be this, which is erroneous because when you have missing parts in a row or column, the top left and the top left is going to take you to the first known or available cell as top left as possible, but not necessarily the most top. So this is assuring that it's the most top left. And because the stuff that I want to find is a column, right? Then I say, well, now that range is like we are here, right? I want to look up in this range. Say, for the entire row, find what do you want to find. This is what I want to find. Okay, look at all the values, go by columns. It's a weird syntax, but it basically searches for the text in this range. So when you find it, you select it. Except when you find it, this is I think there's something about zero-based index or not. So I do remember having to do this -1 here, because when this C is set, there's a column property. So if you happen to, I think this is actually what's happening when it finds this. If you want to find this, kind of puts it here like, oh, after I'm done looking, I happen to finish this and come here. So the C column is kind of like this. So you have to go -1 to select it. That's yeah, you offset -1. The offset is going to take you -1 in the current column you are, which is the current column is the column number of this. Yeah. So this is a cheaper way than doing a for loop. But either way, at the end of this result, whichever one we want to find, we happen to be like right there. Okay. Now, if we want to read a certain row value, we need to offset. Take the value from there. So this is not necessarily returning the value. This is not a function. It's a subroutine. So the reason why I'm discussing this is because okay, if I did something like this, imagine I did this, okay? This is going to change the selection to TMP, but we want to write our values under this new snow probability column. We are right there. We are about to write something like this, and then if we suddenly look for another column for the sake of, oh, let me first find this. I'm in a for loop, so I'll just pass you the correct row number so you can give me the relevant number or whatever. So while trying to write here, we'll be jumping around, and we'll all of a sudden we'll be writing in this cell. That's what I'm afraid of. So it's as if this lookup has to be done first, somewhere outside the for loop. So the column reference should be kept, and this is the same idea with the do. So I can know about the column offset. Okay, before we do any of this, this is a good one. We'll just keep this, right? I will also cancel this. By the way, this, like I said, has to be done way before we start doing stuff. So let's write a command here. Need to collect reference data first, then do the job. Reference points first, then do the job. What's the sentence I just had in mind? Or data integrity. It's not going to make any sense to the next reader, even to myself, but it kind of does. It's about the jumping cursor problem. So find shite TMP. Okay, now this after you do this, you have an active cell, right? It is somewhere. This has a column property, right? I'm going to stick this inside message box. So we have some visual confirmation. Okay. We'll make some decisions. Nothing is happening. We are still creating a temporary snow duration. It's okay to have this multiple times because I have a delete function. So when we come here and we click this, we are going to have another one created pretty much like left to this, but it's going to look like double. But the goal is that during that operation, this column will be sort, and we will be reading the column number, which I'm expecting to read 7. Okay, let's go. 7, done. So now we know the real column number, and here's the duplicate one. This is actually interesting because this is also solving the problem we had here too. We got away with the problem there by sort of mentally enforcing ourselves that we will always clean up the quality fields for TMP and do. So we will always have these 2 right next to this, so we can do 1 or 2 after. But it's hard to keep that kind of order in between this one and these 2. So that's why we are doing this. So there could very well be a function. In fact, let's write that function. Not feel functional today, so let's write it. Function. It's not exactly finding stuff, right? It's sort of getting stuff. Sort of stupid name, get column for. Ideally, it should end with underscore column. Searched item entity column. Something like this. What are we searching? As variant. This is going to return. It's actually going to return an integer. And you do this. This is weird, but say this is actually going to use all this with what, and here you are in active cell, so this is where we do the active cell column, which happens to be the result. So when this is not you're coming from C, JavaScript, all those ECMAScript type of languages. This syntax is weird, because here's where you are defining a function as its return value. You are writing to the function name. The value you want to return becomes the function's value. Like, it's the function declaration. Happens to be the value. It's just weird. I don't know what they were smoking. This is what it is. And to call subs within functions, you have to type call. So the next block. Okay, another corrupt link has been eliminated. So now searched entity column is in fact doing what we are. No. So we should be able to do something like searched. This is going to be a function, UTMP. This is the same thing as this. Well, without the message box. Okay. So find stuff, read the column, which is down here. So search the entity column. It's a terrible name right now. I'm probably going to work on the name. But this is a reference for the TMP column. Okay. So now we gotta do the same thing for view. Now this is automatically pay off for us in here. If we wish so, we could actually do it. We would have to change the syntax so that it's not relative column like 2, but it's sort of like, well, always go read from 7th column or whatever that number. This is kind of okay enough for now, because we will have to figure this out right now here, in here anyway. Can I write this? In fact, we are kind of going for the explicit in a for loop. There's kind of an internal, like implicit for loop here. It's just a formula for you, but here you have to kind of know it. So these two are, could store them here for now for us. Let's create dim. It's your variable in VBA as far as I could decipher. Sometimes the situation, looks dim. Can joke about that like that, or I don't know again what they were thinking. Dimensions, dim, I don't know. I'm learning VBA as little and as much as possible to get this work done. So dim variable is going to be TMP as integer. Then another one is for due. Unfortunately, you cannot do something like this in VBA. I sadly discovered it too. You gotta first declare stuff, then you do this. Checking if I have typos. I do not have typos. It's looking okay. We need to collect reference points first, then do the job for not shifting selected cell around. Now do your work. Okay. So we add our stuff from here. Now we are in the right cell. Let's do very, very, very basic formula. We are still in the right row, and the column index will be TMP. Let's do something like this. Do you have something like this, or do you automatically reference the value? I think you do reference the value. Let's say 100. Okay, this is a valid formula. So this formula is essentially saying it's looping over these cells, and for each cell it references the correct row or the same row, but the column will be the reference from TMP. So it's going to read this value, multiply it by 100, and it's going to write it. And it's going to go to the next loop, or next iteration, the for loop. It's gonna look the same row, the TMP column, times 100. Alexis Schulz, you have been blocked. I don't even think that's your real name anyway, but keep pasting stupid URLs, you'll be banned. Okay, so let's hit it. This is again going to add another column here. And the formula will be written in the new probability column, which is going to be 1 to the third one. You of course have mirror. Things will not look good. This has been done. Let's see where we failed. At times like this, sometimes I close stuff to initialize. That kind of error scares me sometimes because there's so many. The whole thing is sometimes weird. Let's remove redundancies. Done. Temperature done. Dew done. We don't need to know humidity yet. In fact, I want to keep these two extra columns so that I know my stuff works. Split snow, calculate probability. Method range of object global failed. This failed. I know one cell range is possible. This is when we go and seek help. Let's look up range. Although I'm in Excel, it's looking up everywhere, so let's see. How did I do this the first time? From here, I think I find my where. Cell range. So this is possible. I know. I'm using it. You could also do something like this. Cells value. You know, it could be as simple as this. This was missing, perhaps. Let's test it. No, that's not the one. Hit this. Although this sounds correct. By the way, this doesn't even need to be this way. So cut this, right? Yeah, I'm in the middle of writing it, so let me check this. Let's say the formula is 100. Okay, I bet this is still going to give an error. So now we know the problem is indeed here. You know, I think what I'm doing wrong. When I'm using something like this, I am directly accessing it anyway. Now this used to bring up the... This could very well be this, because... Where is it? Cells. It cells, they're automatically returning a range object. And range has a formula property. So when we say go find me this cell at this row and column, this should be done. Okay, fingers crossed. Do it. Done. Now we have to smarten up and something like this. By the way, there's There's Formula 2, R1, C1, classic Formula 2. In this case, they are kind of doing the same thing. This lets you type in this fashion. It's a relative column format. We don't really need that. I'm just keeping it. Yeah, so the TMP columns row for the active loop iteration. Whatever that value is, we'll multiply it by 100. This is just going to be another mini test. So instead of hundreds, we should now see 1600, 1000, that kind of thing. Do it. Done. So that's taken care of. Now we can do the real calculation. Now, this is where the math kicks in. We'll bring in elements from this madness. And I think that will happen after I grab some water, come back refreshed. The stream is otherwise continuing, so see you very soon in possibly a minute. I gotta quickly remember what I did here too. I have a good idea. Good. But this still has a lot of moving parts too. Yeah. Things actually mattered more when t was minus. Yeah. This probability. So based on a threshold, we will say, well, okay, the probability you're calculating it as 79%. We'll say if it's 75%, we'll say, well, okay, 79 is more than 75. Therefore, it should snow. We should actually have true or false in here. So we're not looking for decimal values. We are looking for Boolean statement. And then based on that Boolean statement, the next job will be to calculate the amount for possible true values here. So we'll do some kind of distribution function later. We just need to know whether we should trigger that distribution function or not. We have a lot of redundant probability things here. Let's delete those columns. Also, when we look at these numbers, they are it's not 16 degrees, it's 1.6 Celsius. Okay, it's 0.8 degrees. Let's not forget that. According to, let's do 1.6. I think I was able to. Okay. This is triggering these two conditions. Well, actually, the first condition, P positive, is triggering YP, which is this formula that I wrote, which is basically the possibility of snow. Now, I gotta find that scientific article. Seed organization, urban farmer, under discussions. We did have equations, I believe, and here, did I save it in a PDF file later? Let's open that. Let me quickly browse this. Which reminds me of, okay, this is it. There is another web page which has a simplified version of this graph. This is well, okay, the upper one. The probability of snow at temperatures just above 0. So in 1974, this dashed line, back then the research they had, let's say, gave a probability function like this. Okay, it was charted out like that. And in the recent years, I think this study includes 11 weather stations in Colorado, and these diamond shapes are the measurements. So between 74 and late 2000, well, the last decade or so, the probability hasn't changed much. So we still think, and we have confirming data that it could snow around these temperatures. It's actually 40% when you get to 5 degrees. That's actually really pushing it. In fact, you could have snow most likely 1 or 2 degrees above 0, right? And then, which led us to asking another question. Looking at a graph like this, does it always snow when it's in the minuses? And I know for a fact it doesn't, because having lived in Toronto for over 14 years, it doesn't always snow minus degrees. And that actually led us to come up with a different equation, that when the temperature is less than 0, we it's somewhere here, which is this H, and H stands for I'm gonna get there. Like, that's what I need to tidy up here. So I created the conditions from scientific data that which was represented better in this graph format. So here's what I found. Say it's -2 and the dew point is -4. There is 86% chance of snow. And I've been observing real snow, real conditions. I kept an eye on this and this. And in fact, it really snows above 85% humidity. And looking at this graph, this is 90%. So like, you have a great deal of accumulation right over the 90% or 85. Like, this is where things really look promising for snow. I first had the tendency that, like, as if this was like, it's always snowing. It kind of gives you that feeling. It's not like below 0. Is it always snowing? No, it doesn't always snow. Like around 70. This is 7. This is 75. At 75%, you still don't have that much snow possibility. You gotta get over 85, that kind of thing. So that's going to be our threshold for the minus degrees. So here it is likely that it's going to snow. It's a small chance because it's close to 85. So the difference, the higher the difference, the more likelihood of snow. Maybe instead of having a Boolean value here, this probability column, instead of just having false or true, maybe we'll have a case where, well, it's true, but also less likely, right? So we'll have some kind of qualifier there, that sort of thing. It's all coming back. Where should we start now? In here. Essentially, I just want to see the harsh cases before I fine-tune it, right? Like sort of rough stuff there. I'm going to create a function here. This is not a utility function because this is specific to snow probability, hence snow module. Although this is calculate snow probability, I don't think we can do something like this. This needs PMP as, let's give it double, U as double, and it should give, let's say Boolean, right? So this is the temperature. We'll do calculate. Oh, so here's a catch. Is this the sub? Is this the sub? Which one of these is the function? So since this is a function, and functions kind of, they return a value in the format like they kind of look like properties. So this is in the end going to be something like false or true, something like this. Imagine we are going to do, and what we are trying to do here is essentially this. No 100 business, it's this. In fact, when we run this right now, argument not optional. Okay, of course not optional. You are correct about that. For the first time, right. This. Okay, it's all false. Okay, of course it is false. That it's false. Let's make it right by deleting it. So after that brief goofiness, how do we calculate the probability? Let's say if temperature is, you don't write if like this, you write it like this. If TMP is, how did we write this? Strict equal, okay. Do this, 0, put 0. Then you do end if, right? And inside here we'll have else. And then, because we are still slowly testing things, if probability, what happened here? If temperature is more than, is greater than 0, what? Why is it changing this? Yeah, okay, it's enough then, I guess. Sure. In some languages, that's a problem case. You kind of have to write it in float format. But this is Excel, what do I know? Okay, so anyway, If TMP is greater than 0, then probability is true or false. Otherwise, it's false. Okay. So we deleted it, calculated. So a bunch of trues, then we have false. And intermittently, we'll see false here. Well, this is January, so a great deal of false will be here because temperatures will be in the minuses. So, and then you have the okay temperatures. After 2 weeks in January, we have positive temperatures. Yeah. So that is good news indeed. Back to the area here. TP stands for positive temperature. I had to come up with statements like T when it's positive, T when it's negative, because if this was sort of an organic process, I think in the end. Oh, okay, I remember, yeah. So it's not like I left it by mistake. So when T is positive, this slider didn't have the accuracy or the precision. So that's okay. That's the reason why things didn't kind of happen. When T was positive, okay, nothing I did here was changing this. When T is positive, we are switching to this sort of fine tuning slider, right? But essentially, these two will be the same in Excel because we will have those precise values. And similarly, the precision with the dew, instead of this, we are using this. Well, yeah, not in this formula, but in the HP, we are using the DP. So it's going to converge to the same value in Excel. Let's do TMP greater than 0. So let's write the basic formula, then break it down. It's this. We put this 100 here minus so that we would actually get higher the value, the better sense we have that it's supposed to. Because before this, things were looking like, this would have looked like 14%. We don't want that. That's kind of what was happening in earlier versions of Dungeons and Dragons. You would roll d20, but you would try to roll low, and now they changed it to, well, the higher you roll, the better it is. So we will most likely have some kind of probability here. It's double. We'll say probability is 100 minus some HP value, which is something like this for now, minus HF. Right? This formula is correct, except the references are missing. And we'll have a mini if-else block here. We'll say inside we have a big if else, if the temperature is greater than 0 or not. But in each case, the probability we're calculating, that is going to be checked against the threshold. Yeah. And I'm thinking, while I'm describing it, I'm already thinking, can't I merge those two functions so that we have one distribution function instead of two, t0, t less than 0 or not? Because essentially this is what I'm doing. For t greater than 0, I'm creating a function and I'm going to check the value against the threshold to see if I'm actually in this zone. And I'm going to do something similar for t less than 0. However, when I look at this area for both these, the functions may change, but kind of my result set is in the same area, or I have similar results in both sets. I think the desire to separate it into two functions was because, like I said, as the temperatures are dropping, you go to the left like this. The possibility of snow was increasing to the point that if it was less than 0, yeah, we couldn't do that with one function because it was quickly converging to 100% snow possibility if it was less than 0. So we had that switch there. Yeah, I think we still need to do that. Okay, HP minus HF. What is HP? Something. My eye goes to this HF. Let's do this first. And this actually looks like a good function. This is going to be HF. It is going to take, what is it going to take? Temperature as double. We'll pass things around. This is going to return a double. This is going to be an interesting function to write. I'm gonna freak out here soon. Yeah, freak out. Please. Okay. HF equals, let's try to fix you, 9.5 times. You don't write exponential like this, you write it as a number. And this part is the whole exponential, and now you do times. So now everything here is the exponential, except this curly brace is part of this. Right? And whenever you see this frac, it's a fraction of this over dp times, I'm already guessing the look of this, yeah, this over tp plus something. So we'll do the top part first, minus 17 something, c dot, which is dot, like multiplication dot, shorthand format. This is actually this, dp, which happens to be our TMP coming in. This over, you are now TMP plus this madness. You turn into this. So it's done. Yeah, screw you. TMP. Let me, we don't need this. Let me wrap my head around this. By the way, because this is 9.5 times blah blah, right? This could very well be coming from like just before let's in fact do that. Okay, so then it's easier to read this part. So here's term A over term B, term A, term B. The result of that, it's the power for exponential. So this is it. So given TMP, HF is calculated. Now this is going to be calculated here, except we need to pass the TMP. Why it's going to complain. Now we gotta do something similar for HP. The reason why I typed HP is the same reason that I've been typing TP in Desmos. That's when I tried to perhaps over-optimize this, but here's what I came up with. The reason, here's the reason why I have HP and HN, H positive, H negative, and H stands for humidity here. This is the relative humidity formula that we have been using in much everywhere. So it's some exponential that takes into account the dew point over similar formula, the same exponential, but this time it's using temperature. It's essentially dew over temperature kind of formula, right? And this 100% is just a convenient way to turn this into sort of 89% weight. Okay? This is not relevant. This is the relevant part. And if you consider is the same kind of structure, it's dew over temperature, generally speaking. So the closer dew is to TMP, the more saturation you have. It's going to get closer to 100%. So if T stays the same and dew goes lower and lower, you are basically dividing a lower value to a higher value, so humidity will fall. It's like, in fact, we know that. Similarly, if, like I already said, that dew, if it was approaching TMP, you'll get 100%. And it just happens that the way it's defined, dew is never going to be more than TMP, because you cannot have more than 100% humidity. That would be like you're already at sea. It's liquid all around. Well, you do have that. It's air, like it's moisture, but there's no such thing as 120% humidity. There's a cap for it. So the reason why I'm talking about this, why should it be any different for negative temperatures? In fact, it is not different, but I created my own reality here. So normally for negative temperatures, this is what you use. Just the numbers are negative here, but negative over negative, it turns into a positive. Like right now in Toronto, we have both the temperature and dew point negative, but the humidity will still be positive because like this over this is positive. Basic math, fine. But what I'm doing here is this S factor here. Badly chosen. It's let's call it exaggeration factor, right? It's a game. We want to fudge numbers. We want to make things look more drastic. So when I included this exaggeration value, which is presented with this letter S, which is basically saying for every 10 degrees below T, S is incremented by 1. Can I keep this here while I'm testing it? Okay, let's do it this way. Say it's between -10 and 0. Okay, this is still going to be 1, which means in this condition HN is pretty much the same thing as HP. Nothing is different. Right now the result here will look different because we're doing some other monkey bit, but it's essentially the same formula. This is 1, which is this. This one is using DP. I have to make this the same as this. That's not going to happen. That's going to fix itself in Excel. So let's go here below -10. Now S is 2. So this is what I noticed when you introduce this coefficient, this exaggeration multiplier. Kind of the numbers look drastic. To simulate this sort of behavior, generally, the colder it gets, the more difficult it is for snow to appear. So this formula is satisfying that condition. So in fact, I'm going to play with it. I'll say like just -10. Okay, I'm not changing due. And this is a very valid case. In fact, we could have almost 10 degrees difference. So this is actually within the realm of possibility. This T -10 is S equals 1. So HN is 61%. As soon as I go 1 degree below -10, my relative humidity drastically drops. And for snow to appear, this has to go over 85%. So I'm making it even harder to get over 85. So I'm kind of fudging the relative humidity function so that it, numerically it's harder and harder to have snow. The only condition that you could have snow is, of course, when dew is approaching T, then the probability is increasing. This is, in fact, based on my... I played with this a lot. Then this guy really plays a role. I mean, it already plays a role, we know that, for snow formation, but it plays even a bigger role when things are exaggerated. This really has to be closer to T. And I haven't charted that out, but it's somewhere. Like, say, for... Maybe a better way to phrase it is, when you have the same distance, same... it's like 4 degrees difference, right? The probability distribution is not the same when this is the same 4 degrees, but at different temperatures. Things get worse and worse, like say 21. This is the same, 25. Let's look here. 70%. Yeah, 72%. So yeah, this is exactly what I was planning. So from 72 to 70%. So as things got colder, the snow probability is decreasing. Like in this case, it dropped by another 2%. Maybe that's not much, but this S number is definitely giving us. And by carefully adjusting of this, could actually make it even better. Maybe 10 is just too large for it's a large interval. Now if you decrease the interval, then you make things more drastic a lot quicker. Instead of Like -11 is the first number when things start to look desperate, right, or drastic. But if you do 5 here, your range, then this is already at the second level of drastic, because -6 would have been the first level of things looking drastic. So making this 5 at this -11 is the case when I was displaying -21 when this was 10. Nevertheless, let's try it, and then right away we'll see a big drop here. So this is 48. Let's do 5, and yeah, things are looking really, really difficult for this. However, this HN is also factored in. That's factored in and ultimately represented here. So 72. Kind of curious why I did not see any change here. What am I missing? HN H. Oh, I think I at some point I changed this. Yeah, this should be HN because yeah, this is going to change things like these two because it's changing H. I get that, or they change HN. The difference between this one and this one is really S, but yeah, changing these two will definitely change these two. But I'm not using HN, I'm still using the default. So what was I doing there? So I need something like this, but instead of P, I'm going to use. Now we have that 29% here. This is the difference I'm trying to use. So when instead of T over -5, you do 10. And all of a sudden your snow probability is going higher. Now we can, I think, really test this gap. So the absolute value is 4. There's 4 degrees difference. -11, -15, right? Let's take this down to this 16. This one to 20. 45%. We do have, yeah. So this is exactly what I was hoping. It is really, really exaggerated. This is actually the minor, the mild case. It's still -10. When it's this cold in Toronto, it's usually clear sky. We don't really have snow. This, in fact, is a very low probability of snow. So to exaggerate that even more, so this is what happens. Now let's look at -15 to -16 to 21 low. Again, I don't usually see snow. 11 to 15. Still low probability. As it's getting close, so let's try 11.5. This is why this thing was driving me nuts. Just do it, man. Yeah, and even then it didn't do it. So that's why I created this narrower range, or otherwise I have to type it myself. The probability is 80, 90, 87%. Yeah. So this is in my mind, this is a good probability case, higher probability case. And I'm just trying to see if it's around 85. Because either I will change the threshold or I will fudge these numbers to fit the observable data, which is 85 humidity. So now we go this way. This is still the -5 threshold. So let's do this. Okay, see, this is kind of working. I wish I had I think I'm kind of clear on this, but I'm not sure if I'm communicating it clearly. I think visually this is what I'm going to use. Let's assume this is temperatures. And I think I could even create some, let's call it, fortunately I already used T as the temperature. So I'm going to create a new, let's save this. Temperature is going to be -5. And I actually want it to be, let's see, create this as, nope, x is -5. Thank you. And then I'll have another x. I can actually do it t of x, right? Yeah. Have another x. So, okay, color-wise, it actually makes sense. The red line, air temperature, the blue line is the dew point. They are 5 degrees apart. If we shift these two values to colder temperatures, but the distance is always the same. The idea is that although when dew is close to T, it should increase the snow probability, but by the same token, if you have the same distance, same temperature difference, under normal conditions in real life, the probability of snow shouldn't change. However, in the game, because the data looks so skewed for us, we are treating as if, although the range is the same, but when the temperatures are here, it's going to be even more difficult for snow to appear. That's what this is doing. So this exaggeration factor is making things harder. So even if the difference is the same here, -1 or like 1, right? This is really when I actually get to see snow. This is right over 85. We could perhaps put a threshold line there. Call it S. Well, we already have S. L as line 85. Doesn't work like that. How do we do this? Okay, LFX, this will work. There. Okay. That's my threshold line usually. -4, -5. We should have snow. Now, I'm going one down here. Of course, 100% snow, but one down here. If I keep doing this exercise, I go one by one for both. This probability will approach like no go zone. Let's do it. 7, 9, 8. Yeah. So as it's getting colder, it's getting harder and harder for snow to appear. Yeah. In other words, this sort of this probability distribution here is kind of looking rectangle here, right? We are making this kind of like a triangle here. You have a higher chance here. Then a lot of these diamonds will disappear in this area. They will have to be pushed up. You really have to approach over 85%. So this is sort of like you already have kind of a pattern here, like. And then my concern is okay. This is still good. -8, 9. This 9, 10. This is still good. Well, it's actually right below. Mathematically would fail, but I'm also able to fudge the threshold too. And it's slowly, ever so slowly, it's going away, like getting down. Yeah, and now we are really exaggerating it. And when this gets to the 15, actually this has to be one down. Really exaggerating. So having this difference of 1 is really not cutting it at temperatures this low. This has to be now. This even then is not cutting it. I almost want to kind of go about this in the middle. Every 7.5 degrees. Right. Let's go back to 10. Yeah, this is when it will snow. This is the question. Do we want it to snow at this temperature? Is the question. Let's apply the formula. Then this will return true or false. And then when we populate this area true or false, we will look at the existing data here. I'm gonna try to make sense out of this one, and whenever I can see some values here, these true falses, we will make an educated guess or some decision, so that we can adjust this threshold value too, because that's always a good question too. Like, we have a bias here, but then why do we have that bias, and it's based on what? Let's get going. So, although I have been discussing this all along, I still have to finish the H humidity for positive value. So all the stuff in the last 10 minutes was about the negative humidity. However, there's actually a reason why I discussed that is because there's practically no difference between HP and HN, except S is always 1 when the temperature is positive. It's not going to... is it actually showing it here too? Let me think. This was a weird case, but mathematically, let me think. When T is positive, is the code we have in VBA. Let's say it's 5 degrees or 10 degrees. CL minus 1 will... I think I need to create another function if I want to consolidate it. Ideally, I don't want to write two functions like HP and HN. I want to keep one method like HN, which always takes an exaggeration value or coefficient. But in the T positive, S is always going to be 1, so we are going to treat it like normal RH, which is in fact calculated in a different module out of a formula, but it does that based on those two columns. We might have to replace this in light of this new information we are working on here with the for loops, this sort of stuff. For now, let's create a function and we'll say just having a brain freeze. How do you type exaggerate? Exaggeration rate ratio. I'm having a hard time remembering it. I think I'm correct. Exaggeration, yes. Exaggeration ratio, which is going to take a temperature value as double, and then it's going to return integer. First of all, if TMP is positive, always return always return 1. Else, to end if else, ceiling. This is the ceiling that's coming from my methods, right? As if ceiling, yes. I'm looking for the ceil function. Floor, perhaps. Is there some kind of a module like math module? Ceil? Ceiling math? Ceiling math. Rounds a number up to the nearest integer or to the nearest multiple. Okay, that's what we are looking for. Hello? I feel uneasy when this guy brings up, IntelliSense works for some things, but then it doesn't for other things. I think this is the formula. Minus, well, T over minus T, it's minus T over 10. And because I'll call it range as a integer. Range is 10. Just do things right. So we'll change the range to make it more tight or more loose. Okay, this is it. So we have this part here. This is also the yeah, HF is a different humidity. So this is kind of the real H. This is humidity with exaggeration. Call it this for now. This is supposed to take TMP and do as double. It's supposed to return double. This is the formula for Excel, but in VBA, this is the function. It didn't matter actually in the end. It results to the same thing for uppercase, lowercase purposes. When I did this, I did not divide by 10. This would definitely fail because I'm now noticing that here. Every temperature that I see, whether it's dew or air temperature, I should be doing this. This is not going to matter because it's absolute values. Here we go again with the dot. Yes, it doesn't matter. Anyway, we have to validate our findings soon. I'm guessing this is going to be calculated, yes, before this, and this is, yeah. This doesn't matter. So it's sort of done here. We have to replace our C2 with dew. Then maybe we'll find R2D2, right? This. Here we go again with the pound. It's pounding on us. This is missing the exaggeration ratio, which is something we do. So we do exaggeration ratio TMP times. You gotta include that in here. Here. This looks weird here as if I'm mixing in TMP with dew, but the exaggeration ratio is calculated based on TMP, because when TMP is really low, it's also pushing the dew low, or lower. It's fine. There is no need to write another exaggeration ratio based on dew. They are kind of related for reasons I discussed earlier. So this is why is this HW? Didn't I say, okay, I made a typo. W and E, I was supposed to type E. Exaggeration thingy. This is not going to work unless we return our calculation, which is returned like this in VBA. So this yeah, I'm really mixing things up. Okay. If temperature is greater than 0, do this. Oh, yeah, now this turns into HE, because I was supposed to calculate HP, which is sort of this, with this being 1, and we satisfy that by this excitation ratio being 1, and this is essentially the same formula that we are using. It's the same result, but we come to that result through other means. Where is it? By reading cells, and here we do it kind of mechanically, not automatically. Where is it? Here. Okay, so that's that. Okay, and there is going to be some if-else check here. In fact, in the end, I think I did something like this. In my mind, last week at least. Said whatever. It's like if prob is 85. 85. I'm not sure if this is the right syntax, but of course it's not. I think there is a single line. If quickly look that up. Methods worksheet function methods. Did we find if here? But these are Excel things, not VBA. Yeah, I'm having a hard time finding Excel specific methods and VBA methods, although this is VBA reference, language reference, concepts, conditions. There you go. Okay, how about sort of true false? Yes. Yeah. Isn't there like a ternary? Ternary operator? If blah blah, then this, otherwise. VBA ternary operator. This. But I don't want to use the if. Fuck it. So first we calculate something there. We say then, okay, and if. It's kind of lame. Not true. Else. False. We don't just do it here yet, and then we'll do probe. So when TMP is less than ideal by n, which is hn, this could have been just hn. Hn is just this. So I'm using the same exaggeration function or calculation, which happened to be the case, sort of scientifically. That was the finding 10 days ago or so. We are essentially turning this. Probability is HE. And as I'm writing this, I'm already noticing a mistake. For HE to work, we should also pass do here. That's it. So I think this was sort of the problem, right? This is already giving us kind of positive results, which happened to be sort of a weird case. So then I was taking the difference and how close are they was playing a role in the probability. Let's quickly run this, and I think I'm going to take a lunch break. It's 3 o'clock, so when I say things like that, stuff may take another 5, 10, even 15 minutes before I actually take the lunch break, but let's see. We'll hit this button, and what is going to happen? Let's actually check that. Snow probability, temperature do you get in? This is solid. This was solid. We just fixed it. If it's less than 0, either way, in HE, we are always referring to this, which is doing its thing. What the? And I would have spent the whole afternoon trying to find why this was 10 over range, where 10 range was supposed to replace 10. This is what I tried to do. I thought I double clicked and typed something, and instead it added. Maybe I was distracted. I don't know. This looks right. I'm glad I checked. Then all the rest has to fit in the right place. So let's hit it. Finding columns. This should be as automated as possible. Calculate snow probability. Here we go. Sub or function not def. So does VBA have ceiling? Ceiling function? Doesn't have a ceiling. Math function equivalent. So if you want to round a number up to the nearest integer or to the nearest worksheet function ceiling method. Holy moly. Okay. You wanna be difficult? Be difficult. So here we go again. Let's clean this column. Overflow. Ooh. Let me look in utils. Have I ever used exponential anywhere? They don't have. This is okay. This is in fact okay. Where are we? Snow. So I'm passing the values. Here's something radical. Not this crap. Imagine I'm passing the values already scaled properly. So every time you see this now, yeah, I'm aware. I think I know why, because I wasn't dividing the TMP here. So I'm going to divide it. This is a good refactoring. So this 10 is a different story. This might very well give the same error too, but I think that range is, this was such a high value maybe. Kind of freaked out. Let's go. There we go. So we have an interesting case here. And I think this is a good moment to have a lunch break for me. I will put this stream on the break page. When I get back, I will investigate and possibly fine tune, and I'll try to make sense of these true-false values. They are not, well, they kind of look like they are alternating true and false, but then I see many hours with the same either true or false values, so there's consecutiveness here. And there is either a very good reason, a very correct reason why this is happening. We will investigate it. And after we confirm this column is actually indeed doing its job, then we'll try to make sense of this part. This part here. Okay. For like one thing, I was actually hoping these should be true and pretty much everything else false. That's where the things will have to be looked into. So we'll look at it after the break. So see you soon. Okay. Let's see where we left off. So it was about fine-tuning these false true values. Fine-tuning values to get better false true result. That's where we are. So I'm at that point. Things will fall in the right place, I think. I'm also hesitant to, as usual. Let me look at my functions here. I think what we should possibly do is forget about Boolean. Let's just get this as double. And we do like no probability is the probability itself, which is this prob variable, right? Is there a return statement in I guess I'm gonna have to comment this out. I don't want to do one by one. I think I discovered this comment thing. Go to the top. Let's also this. Let's remove this column. It. Oh boy. Okay, I see some things looking promising, and because this is now a probability, I will also do this shortcut. Let's hit it again. So looky here. We are in the this is actually not -10, it's 1 -1, but we are in the minuses, right? Okay, this is freaking out because of this 99. So we gotta remove the FM16 ones. So which should clear a lot of these weird. This is still not a kosher value though. So let's see. How the hell are we getting this this number? Not that it's going to matter. In fact, yes, same thing. One thing I'm noticing is this. Wow, this is consistently broken. For the same values in 2 rows, we have same results. I'm also paying attention to this. I have 18,303 or 310. Close enough. So it's this 0 is sort of skewing things, like, you know, it's like this is as if like there's 10 difference. It's not. It's actually 1 degree to 0 degrees. This is 1 degree to -1 degrees. Okay, that's what it is. Let me see if I can find another weird range like that. And pretty much all the minuses are okay. It's the positive ones that are foul. Checking things. Yeah, I think day 14 we were going over plus values. So we should see some freaky values. Yeah, there. So most definitely temperature over 0. So here's how we can debug it. We can truly debug it, but also logically debugging it. It's temperature over 0. It sure is. So 100 minus something. We get a result like this. First of all, this should be giving us minus result. So that minus minus is plus. So we're essentially getting 100. So in reality, this is 17,340 something, right? Now, how would you get 17,000 here? You would get something like 20,000 here minus 3,000 here, but let's not forget that this is supposed to be minus. So this is like maybe 3,000 here minus 20,000 here. Right? That's how we get to the 17,000 ranges, which is really huge. Now, it's sort of easy to get to the bottom of this. So forget about all the hundreds, right? Let's assume our suspect is HF. We just say, forget about everything. This is it. Now, whatever is HF is the probability. Now, we shall see. So one of these is duplicate, so bye. So yeah, let's put this to the test. Temperature is 1.6, okay? So 238 this plus 1.6. So we have 240 something, okay? Then this times 1.6. That's not what I asked. Okay. This over this. Okay, it's honestly driving us. Okay, this, we call this screw it, I'm typing it. So over 239. So it's 11.5%. So do XP or Clear. Would you recall this like the last one? How do we do that? Memory recall. Okay. This is clear. Add. Okay, do it again. 27, 6, 3, 2, or do exponential. Okay. This is not correct. This is okay. Something is not really working. Okay, let's store this in memory. Okay, edit, done. So, zero everything. Now, we want to do something like this. E to the power, we call memory, equals some horrible number. Yeah, this to the power this is 1 something. Okay, store this times 9.5. Store this 10.5 minus 1.6 times, we call it, is 105. This is kind of what I remember. 1.6, in fact 1.6 there. In this calculation there is no due, so all we have to do is this is going to be above 0, and this is not going to matter, this is going to matter. Right, it's yp is over 0 yp. In this case yp is this, but if we only took into account hf, then it would have been hf. So in fact we could kind of do that. Let's say it's not yp but it's this, so not hf, it's hp positive, correct? Let me see. No, in fact it's hf, that's what we are trying to calculate. So then the value we are getting is 75. So even this is wrong. What is happening? So here's when you open a new Excel file. Let's call this TMP. Let's call this HF. Let's write our formula. This is sort of getting out of hand, right? Where was it? Let's write the exponential part first. This XP. Let's say it's A2, something about A2. And we do 1.6. We have 9.5 times this output times this minus A2. Okay, now this middle section is minus 17 times this. Okay, This is doesn't put the brackets in a smart way. Or A2 plus 238.3. And I'm going to put it like this so that these are always at the end. Okay. 75, 35, something. So HF is giving us this. Okay. So when TMP is, I could put 16, but I'm feeding it into the function already divided by 10. Yes, I do. So this is doing it wrong. So this HF, which is output, I mean, even if I don't multiply by 100, actually no, this is correct. 75. Oh no. That is correct. Oh. I understand why. One of these, the one that came from that website, is already converting it to hundreds. And here I don't, so I'm kind of forcing my result to turn into. So it's in essence, it is supposed to be like that. So I do my correction elsewhere. Remove. Okay. This is consistent. This for positives, we do have results here. So when I say 1 here, we will have 83. Okay, this is correct. Now, HF is done. HE is not done. Now, I'm fixing HE here, but this is the problem part. Maybe maybe here I actually do. There is actually a reason why I did not do this in the other function, because I wanted to get to. I thought the values were already normalized, right? Between 0 and 1, so there was something nice about it. So this might actually work. Let's switch this back on. Now this is going to come already fixed, which is going to be fixed. This always comes fixed anyway. That's what we deduced. So this might actually work. So this is somewhat correct. This is the wrong one. Now we expect everything to be fixed. Actually, I'll just put a new. Okay, this is more like it. Now there's nothing. I mean, I could write a validator here that actually checks if there's any value over 100. But I was just about to say I'm confident, and my confidence level is very low right now. This is also expected because when I was creating this best-most calculator, I did have cases where things were going over 100, and we were going to clamp that to it snows anyway. So that's that case. However, having 10,000 percentages, it's nonsense. This is more. This is expected. So let's go to 14 day, and this is going to be pretty much correct. 15. And we happen to have those cases when the TMP is usually 0, I believe. It's 130, go up. There's this sort of change here. That's when I noticed. Go to the top. This one. Yeah. So that's what I noticed too. So we could easily clamp the. Is there a clamp min-max stuff? What was it? Worksheet function clamp min-max just max. Let's ask Google. VBA clamp function. I'm looking for the. I could do this, but I don't want to do this. I don't think median is our. This is pretty much what I'm seeking. If x is less than lower, then yeah, clamp it to lower. Otherwise, it is what it is. So let's just take this to our utils. Put it somewhere. Pressure, snow. We'll do clamp like this is never going to be a problem because it's already clamped naturally by the function. Sorry, my yes, naturally this is going to be clamped. This is not clamped. You can say clamp. Here's your value. It is going to be lower 0 or 1, except it's already in the range of 0 to 100. So let's do this. This is not correct because it's missing this. So now when we run it again, this should be 100. Of course, you leave garbage like that around, it's going to bite you. It's corrupted, go away. This is the one we are. What the? Chef. Are you sure you're doing it? Oh, you know what? That was actually doing its job too. It's my mistake. I should be clamping the result itself. So go back to this as your result. Not this. Clamp. Do it again. That's it. Now we can check whether this is 85 or not, whether it's snowing or not. Now, before I do the true false, here's our chance to adjust those thresholds. Let's look at that website where I did some reverse engineering, looking at a graph, snow probability calculator, science bits. Here's science behind it. Here's the graph. So I remember taking this. Let's do some reverse engineering. Sure, this. In fact, I'm just going to abuse this image by doing this. Okay. So it's easier to work with, I think. I might have to revert to the original size, depends. So this is where we are at 1 degree. This. Okay. Or this. Okay. Now here's the red line is where the snow has to happen. So we eyeballed, as we said, here's 80, right? Here's 90, and so around 83% it actually snowed. It sort of snows, right? Which led to the magical 75 for temperatures over 0. So for temperatures less than 0, we want the result to be over 85. But here it's okay if the humidity is over 75. As the temperature gets warmer, then you have snow 60, 70-ish. You have snow in this area. The problem is this actually, essentially. I sort of butchered this equation or this graph. This graph is not a linear graph. This is a kind of a decay function, or it's one of those exponential functions. So let me create this more or less in Desmos. And I think maybe we'll change some of this stuff. Right of that. So let's create a C of x. Let's call you 1. So it's blue, it's easy to read, that's done. Now if you do this, let's say -1. Damn it. Nothing is happening. We change this to this. Now as x is increasing, e to the power of -x is essentially 1 over e to the power of x. So as x is going to the infinite, e to the power of x is going to infinite. So 1 over infinite, you are going to the limit will be 0. So it's asymptotically approaching 0, right? And then if you go here, you are going to the infinite. So this has to be at 100 when x is 0. So you can satisfy that by can I do this? Okay, now we have to adjust the x factor. Yeah, this was supposed to be plus. So you always have 100, and then when x's are growing, it's gonna gradually exponentially grow, not gradually grow, hence the exponent, right? So exponentially grow, but then you want this to approach 0 as well. So here's the funny thing. I think this is already done for us. Here's my exponential. Because I'm going to introduce values here, right? But it's going to converge to this. That 238 is the Kelvin stuff. So it's the absolute zero and such. So we take into account that in this formula. But here's what happens. When t is 0, e to the power 0 is 1. So then essentially it's 9.5 times 10. Right? This is approximately 100%. Remember, this is 0 2. So this is already done for us. So if we shamelessly take this, so when we say g of x, then here the TP is essentially x, we do have that the only this graph is the same graph as this graph, except the scale here is off. Let's just put this here. It's the same graph. Of course, and I think I kind of extrapolated this earlier. This is sort of going. We do that work here, like you extend this line. Where is it going to touch 0? It was after 10. And that's consistent with this too. So at 10.5 by logic, this is 0. So everything is 0. Okay. So if you have the patience and you say this distance is 2, so you put another 2, sort of another half. If you extend this line thinking this is the curve, and you do that with kind of doing it anyway. So this, so you have to put a Bezier curve here. Anyway, there's a derivative of this, so that's the so you let this go, and this line is already kind of giving you that. So I don't know if you can get this time. Let's do top left here. I think we'll need more than, maybe we'll do, okay. Crazy stuff. Oh, I had room, I didn't scroll. Let's paint the town black. So I'm just going to take this shamelessly. This actually already looked like half. I'm going to do a trick here. Okay. I'm going to cut this part out. Then I'm going to flip this. Snap it here. Because I just need the markers, not the numbers. This is 10. Okay. This here is 10. Okay. This is 11. It's 2 by 2, okay. This is 10. This is 11. This is 10.5. So we are really expecting this to this line to touch it here, and that's actually where it is. There's a slight, it's not sitting perfectly. If it did, you can actually fuss with that for like some time. This looks a little bit better than the other time, and yeah, it's going to approach. So it's correct. It is correct. And they also did some approximation here. Normally at 0, you don't have perfect 100. It's less than 100. but they did some scaling to fit things to 100. Because at 0, you're at 99.75. It's 100 enough, but you have those inaccuracies. So this is perhaps what we should use, like the formula itself. This is sort of a force meaning. Now, maybe this is where we interpret things. And here's a close-up. These round shapes are it's rainfall. So at these temperatures, it most likely rain. When you see this square-like things, which is here, snowfall, you don't get to see these guys here. However, when we are following this threshold here, this humidity level, when the temperatures drop at high humidity levels, the round shapes turn into first sleet, which is the in-between phase. Then eventually you have more square ones. So the blue line here is the rain line. So anything between the rain and purple line is the sleet. So you have more of these weird shapes. They look like ASCII video game sort of like player character. And then you have the square ones in between the purple, red, and below red you have mostly snowfall. So it's sort of like this. This is the problem part. This. Because I'm taking a decay function, an exponential function, and I'm treating it kind of linearly here. Right? It's truly giving me the probability. But interpretation-wise, this is how it looks. Between 1 degree and 2 degrees, my humidity level should be here, right? At 2 degree, if my probability, in this case, they actually correlated that relative humidity is the probability of snow. That's the whole study, the whole paper is about that. Then the more humidity there is at the same degree, it turns into rain. It's just too saturated. That's kind of what they assumed. It's sort of just cold enough and dry enough that it actually, it snows here. And here it gets wetter. So the interpretation is actually wrong. The calculation is correct. But now I have the safety that I can actually do all those if checks because I know t is always greater than 0. I think I just answered my own question, kinda. I'm kind of able to write the pseudocode in my head, and I'll explain it, and then I'll write the code. So this formula, which is this. or this, whatever. It tells us what the RH value should be, maximum. Yeah, I've been going about this the wrong way for t plus t over 0. This calculation is about the logic is reverse. So the answer is going to be something like, we are going to ask our function, and it will say, well, you know what, at this degree, the highest RH you should have is some number that the function is returning. Anything below that in actual numbers, is it less than that? If the answer is yes, it's supposed to snow. That's where I was interpreted wrong. Yeah, I was trying to reverse it. Because if the actual temperature is over that, which is over this line, then you are going to have less chance of a snow. You are going to have some like sleet or rain. We will skip the sleet case. We'll just say snow. If you're ambitious, maybe we'll consider the purple line as because we still have some snow in this area. For now, this is okay. So, in light of this, if this is this is not HF now. This is truly, well, it kind of is, but let's give this a proper name. Let's pick a name like sort of want to use highest, lowest words, but then maximum humidity for before. That's it. Can massage that name, but this is the maximum level of humidity, so that beyond which it turns into rain. However, you cannot just arbitrarily say, oh, below this it always snows, because then you are making a blanket assessment here. So anything over 60, we'll say, and anything less than this, so it has to be in this sort of zone. That's it. Which is interesting because I created my own artificial triangular zone for less than 0. Easiest to you. Maximum humidity for snow to form. And then by the same token, we do have a minimum humidity for snow to form, which is sort of arbitrarily 60. I may make it 55% for this. We'll do that section. So let's create another function here. Yes, sir. Change this. This is actually a constant. Uh, 55. This is minimum humidity. Okay. So when it's like this, we are no longer doing HE, that is its own thing. This has its own thing going on here, which is sort of okay. So it's as if someone else did the same study for less than 0. We could do that too. I believe a Japanese scientist did that, wrote a book in 1954, which is a topic of our previous streams. But I think the representation here is so poor, the images that I was able to find. They did not give these numbers. I'm guessing. But this is talking about snow types, not necessarily whether there's a chance to form snow. If there is a chance, then these are the shapes. That's all other thing. So this is no longer the case. This is going to be... we will even merge this here, so we'll say... I think we will have this. Can you do this? Uncomment. Okay. Got this. Jesus. Yeah, because I'm adjusting my thresholds here, so it's okay to go false or true. Maximum humidity TMP, which is this. Then we no longer have to worry about clamping things. Now we do things like we already know we are over 0, right? If probability is less than or equal I need to calculate the current thing, which is HE. Okay, that's where things will come into place. So HE, if the current this is TMP, gotcha, do if it's less than this, and do this or and dude, relax. So this is the current. Dude, relax. Dim current RH is double. Current RH is this. If it's less than this, it's not 85. That's actually what we are trying to relax. Just driving nuts. And let's not put the end here. If current stuff is between 60 and less than, between 60 and whatever the humidity is. Now, here's the problem. Or will there be a problem? As we go here, let me wrap my head around this because I know this is gonna fall. This is going to give us this line. So we'll eventually get to like 40, around 5 degrees. So 40. Will the current RH be? It could very well be. It's unlikely at the I'm guessing it's going to. I'm wanting this to fail to go into this. I think this is going to kind of recover. There's going to be a sweet spot here, somewhere here. 2, 3, 4 degrees. This is most likely 3 degrees. We do have a few cases like that. This kind of checks out in my mind. Now, and here we are just saying, well, when the humidity is this probe, there is no longer probe needed here. This could very well be this dude. As I'm in the middle of typing it, maybe stop warning me. But then there is no need for this. Which is current RH. We're already doing it. Which is this. So here we are in a special pleading scenario. Here we say, well, it's less than 0, then make it as saturated as possible. And we do that because this is already doing the exaggeration. So it's getting harder and harder to go over this, therefore to snow. If you are really over 85, this may have to be fine-tuned, but we do that in here. Let's see. Here we go. So since these were the values, okay, I want to clean that. Only comments may appear after end sub, end function, or end property. Help me out. Minimum humidity for, okay, minimum humidity for snow to form is also this. Wrong. I suppose, oh, because I'm the old brain. Let me calculate the real RH. This. E2, H2. Yeah, I did that correction. So current humidity is 94%. At 1.6 degrees. 1.56. .94 is, here's 95, well, somewhere here. We are also in so we should not have snow because we said below this it should snow. It's wet. That's what we said. So it is false. Awesome. Similarly, yeah, this is now misleading because my mind keeps going to, okay, maybe 85, this was false, but this should have been true. It's no longer the case. Why? So it's so humid. It's 0 degrees again, like at 0. We are right there. In fact, now you are allowed to have higher. Why is this false? This checks out in my mind. It's too wet because the lowest here is 86%. At 1, 86% we are here. It's wet. I get it. It's not below red line. At 0, oh, it's 0. Anything less than 100 is snow. It's that nice sweet spot, right? Let's close this one. At 0. This is dry enough for the sort of expected 100%. So it should have said true here. That's the confusion. That could only mean minimum humidity for snow to form. This is current RH this is true. Maximum humidity for snow to form at 0 this is 100-ish. This is true. What the? This is a nice case. I'm still thinking about this problem part, but -2 minus, it's not -2, it's actually very close. This is 0.0 minus 0.2 minus 0.4. These two are actually very similar. Divided by 10. Are we okay, our H is 80. I'm considering a different possibility. What if we are in this case? But in fact, we could be in that case. I first negated my argument, but no. What if 0.0 is not really checked here because 0 is coming in and for some stupid reason this thing is failing, okay? And we go into else. And then current RH is 80, so it fails here. So we go to false. So even though we expect to be here, we are never there, and we fail here for a different reason, which is a valid reason, but I'm not sure if it's doing this or not. Maybe that is the statement. Who knows? So let's keep this. And for this line or row 13, where the temperature is 0, we expect to see a different result. We don't. Is it ever the case? Doesn't seem so. Now we go into a different VBA conversation, which is I want to call float, but it's kind of double, right? Greater than double, larger than double. I don't think my values are at that point to have this sort of range issues. Let's call it long, but I don't think that's really the reason. Everything else is pretty much the same. This has to change. This is just a ratio. Temperature is now this. Done. The problem is I still expect to see this, either this or this, which is reverted to this. I don't think my result will change. Let's clean this column. Do another one. Oh, hello. So this was originally false, now it's true. Aren't you funny? So what happened? You were false then, without any numerical change. Wow. So this is the strictly cold case. %83%. We are here. Current RH, which is what? HE, which is this. How did you turn from false to true? Because current RH is supposed to be more than 85. It cannot be more than 85. That's not correct. Either this is wrong, or internally it's calculating this value out of this wrong, which is more likely. Can we do something like this? Since we seem to be checking things this way, can we do something like this? I want to calculate this plus. I'm gonna do something like this, which is really weird. I can see this as going to be a bonus. Good. Now smarten up. This is, yeah. So this is positive cases, and here's a negative case, and sort of kind of failing. Now, we can do better than this. We can do, well, we kind of clearly see if it's negative or positive. I don't need to put another comma here. So follow a similar structure, as horrible as it looks. Delete this stuff. So it used to be false, now you're true. Your current thing is 86. So suddenly this 83 has become 86. How did that happen? So out of minus 0.7, minus 3.2, the humidity went up to 86 from 83. How is that possible? So let's go and refer to our RH calculator, which is here. Celsius. We are doing what? Minus 0.7. And then minus what? 3.2. Calculate. 83.17. So this is correct. So Excel, what are you doing, sir? Oh! That's because under normal conditions, but I'm not doing normal things, right? Because I'm running this through HE, which is I'm also going to make this long. I'm going to divide long over long. I'm going to keep this here. No, that wasn't the problem one. This is the problem. Still 86. So minus 0.7. Okay, let's type this in Desmos because I have the calculator too, so I can verify. And then this was 3.2. So it's 80. Yeah, here it is. We never get 86, even with the exaggerated, which is HN, which under these conditions S is 1. Because this is 10. This is still 10. So I have no idea why. Let's see. So somehow this comes here 86. Why? So we are in the minuses. We are here. So you used to say false. Because at some point current RH was 83. So you said that it was false. Then I did something. Now all of a sudden you think it's 86. You switch it to true. Naturally. Why is this 86? Because this, which hasn't changed, except all this. And when I did a calculation outside, it's still 83. Screw it. Give this long to. Let's do another round. Pull through. Okay, there's clearly something weird going on here. More or less. This is rounding. Let me calculate RH again. I don't think these values are changing. No, did not. Here is 94%. Here's 93%. And yet they are... Shouldn't I see decimals? Is there a function in VBA that keeps the decimals for us? VBA decimal separator, decimal places. Oh, you know, now that I'm saying this decimal, in C# there is a decimal type, right? That's not what I... Formatting data to 2 decimal places in VBA. About precision function or something. Format. Yeah, I'm doing a string concatenation which kills the let's see. Changing the declaration to double was the only... Are we going back to double again? Yeah, I'm going back to double. Sigh. Double, 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 double. Double, double. This is variant, so I can do this. It's doubling. There you go. 83, whatever. Okay, there you go. False, false. This is not the right case. Grabbing more water. And thinking of the next thing. Okay. Let's review. So we have the current relative humidity, or the actual relative humidity, for temperatures below 0, which is starting here. We are executing a different formula that is checking whether RH value is over 85. If it thinks so, then it's snowing. For temperatures over 0, we are running a different formula where we check whether the humidity, whether it's too wet or too dry, that kind of thing. So it has to be in a range. And the upper limit is calculated based on that new formula. Now, I'm going to delete this. Is there a way to write this decision to? It's not mission critical, but it's sort of too fixed. JavaScript. Fixed. Decimals. Worksheet. Function. Round. This argument. You take this, and the other one is really know what this is doing. Can you get help? Not really. Okay, not that useful. Not that useful. Round. This is the one we are looking for, right? Worksheet function. Maybe we'll actually be fine. Yeah, this is oh, okay. Worksheet function round, first one, and then the other one is 4. You would expect the second argument to be not double. Dude, I'm in the middle of writing it. Relax. This. This. So we'll probably do this for the other one. This one. This one. So let's go. Of course, like an idiot, I took for you. This by this. Okay. Legible. Ooh, for this to have this. This is expected because this should not be here. This value should be fixed. This is going to be part of the investigation with view range. If we do it this way, it's supposed to stop us here, and we'll fix this value. That's our task. This is expected. It's acceptable at this point. I will remove this. Okay. So here's an interesting sweet spot problem, which is kind of correct. Correct based on the assumption that we've done everything according to our specifications. Look at the true-false case here. Actually, true-false true case. Look at the temperature change. For argument's sake, well, there is no for argument's sake. Always think of these values. This value is divided by 10. So the difference between these two is not 20, it's actually 2. Yes, another bot bites the dust. Bye. So when you're at -3 degrees and the dew point is -5, the snow possibility is true because it's over 86 according to our threshold rules. Then the dew point doesn't rise that much. It only goes as high as -4.5 as opposed to -5. So there's a bit of warming up here in the dew point. However, the actual air temperature is -1.9. So it actually warmed up a lot more than the dew point because the discrepancy is bigger. So between these two, get another bot. Okay, bye. So the difference between these two in the first row is -20. Let's say decimal difference, right? It will be the same difference if you divide by 10. In the second row, the difference is bigger. It's -26. So, of course, you are reducing the chance of snow formation, which is just going over that threshold of 85. So it is, if it was borderline snowy, yes, it is now no longer snowy. Then, here's something interesting is happening. The temperature drops back to -3. So it was kind of like where it was 2 hours ago, right? This is 17 o'clock, this is 19 o'clock. But dew is rising up and it's sort of catching up to the temperature, air temperature. So there's more chance for snow formation. Hence, it actually goes over the 85 very quickly. It actually even surpasses 90%. So this is actually a good test case. So I'm going to go for -10 cases because we have that exaggeration ratio as a magical 10, right? So the range. So the situation here in the minuses until you see minus like 100, that's where that exaggeration ratio kicks in. You're going to see a more or less gradually distributed humidity values or the snow probability values, right? So this here the differences will be more or less 20, 30, that kind of thing. But as we know, let's actually check that case. Yeah, here these differences are increasing too, because it's 30 here. We never really have 30 here. We even have 40 here. So this is justified. Then, here's something funny happens here. Let's look at line 29. Between, it's minus, but I'm just going to talk about it as if it's some positive value. Between 80 and 110, there's absolute 30 degrees difference, right? It is pretty much the same difference here. In fact, it is the same difference here. But let's look at the situation here. So this one, let me highlight this one, and this one. In the lower three, having the same difference, although the temperatures are dropping, this result set is consistent with having the same kind of difference, although the temperatures were getting colder. This is gradually changing. This drop, however, from 79 to 59 all of a sudden, is the result of this having -10, this exaggeration value. Now, I'm actually questioning whether that exaggeration ratio is needed anymore. The reason being, I introduced that for this main reason that this was sort of complicated, right? And I tried to remedy, well, at least a problem that I thought it existed here in a different way. So I'm making it really, really hard to snow. Goes down, down, down. This is a fluke. Okay. I think I'm going to remove it by keeping this column. Here's the reason why. We do know historically, in the previous 6 hours, at this hour, we had snow. So if all this is false, which is good news, this is when I would expect to see true. Now, all these numbers are quickly rising and trying to catch up to 85, and yet they cannot really, like, despite their best effort, they are trying, and the closest they can get is 79%. And the reason why that's not happening is because I'm enforcing that -10 sort of the exaggeration rate. I bet if I remove that, even at temperature as low as this, because dew is approaching, I think we might have snow somewhere here. Like somewhere here. Well, that's actually true, snow. That's a good case. I'm expecting to see snow here. I should see true here. I might even see true here actually. Line 73. So here's what we'll do. The easiest way to do it is hold is a new function, the constant here. You'd relax. Let's accept that's a function. Okay. I'm going to do some. See, we cannot really return, but what if I do this in the end? It's all one. I'm going to run this again. 73. Right? Was it? Yeah, true. Okay, this is what I'm expecting. This is a good case. This is good. Any difference? This is 24 difference. Close enough, but not there. But look at the difference. Was trying really hard, 65, and it's like now it's actually really 82. True. Yeah, this is a close call. I get that. This is the same case as this, so it should 85.29. Not with the same probability, of course, because the calculation is, the numbers are different, but close enough. This is a fluke. This is good. Do we have more true here? Same situation. They have not marked this as snowy condition. This is what we are actually after. So it's good that most of this is false. We may chalk this up to some weird case. However, this is something I might have mentioned hours ago at the beginning of the stream. The goal was to distribute these, fill in this missing part, right? We were going to do that by distributing the next known value. But instead of distributing that to all the missing fields here, we are going to take this and distribute it in a smaller region than all the way to the top, which is a big improvement. However, this might be a better measurement, which might be taking care of cases like, let me find a true case too, this one. Now they haven't actually marked anything here yet. This one, okay. I'm gonna try to find the definition of this, AJ1. I'll do that first here, then later in the documentation. We are looking in index cleaners. Okay, let's go here and then the identifier that denotes the start of a depth is actually snow depth. Data section. And this is the result that I pasted here a long time ago. Bullshit, we are using AL1 instead, but now we might actually use AJ1. So let's look at the documentation for this, which is not here, which is, where are we? This one, there. AJ1, this one, snow depth data. So the first field is dimension, the depth of snow and ice on the ground. One. What's the unit? It's centimeter. There's 1 centimeter of snow on the ground. The second field is the condition. This is basically kind of a quality code, and I have seen oftentimes that when there is the measurement, condition code is missing, which is sort of like, which is a funny meaning, because if they put 1, let's look at that. You don't usually see 1. Like say you see 3 or 9. So 3 is trace. So there's a trace amount of snow. That's the interpretation. And that's why they put all like 9s in the depth. So it's like, instead of typing 0, 3, they type like 4 9s and 3. So because humans are generally or inherently stupid, they came up with all this stuff, but the way they fill it out is just stupid. Honestly stupid. You could watch all the other streams, me cursing about this. Cursing at them, so. Long story short, this is something we won't rely on. And there is the quality of the of that data. So this is about the condition of this dimension, but this is about how well this whole thing has been collected. Okay, which is generally 9, which means it passed gross limits check as long as element is present. So if you see a value, but this is 9, basically, if the element is present, assume it's been done okay. Normally, it should be 1, which means it passed all the quality control checks. It is rarely 1. So you feel sort of suspicious, right? You look, it's like, okay, 1 is okay. Like, these are good values. Then you have a lot of missing hours here. What happened here? Which is the problem in this case, because this is even more incomplete. And then we go to the next thing. So the first field was the snow depth in terms of snow and ice. But this one is, what if this snow or ice melted? What is the equivalent water depth? How deep the water could be, might be, if the snow melted. Okay, this one is in millimeters. And lo and behold, they actually didn't calculate that either. Which is, I suppose, acceptable. Just making our lives difficult, but let's say okay. And this is the dimension of that water, if it melted, the snow melted. And this is the condition code that's checking this. And this is sort of checking these two. Same idea that this one was checking these two. We have sort of quality control not done. It's, as you can see, the last 3 fields are all the way 9. So here's where we might be interested in, like, why we might be interested in this. If this is missing, this is the snowfall itself. This is the accumulation. So each one has its meaning, actually. So it's sort of nice. But I think I'm going to reserve the AJ1 for a different day and purpose. I think that is going to have implication on the shader code that I'm going to write. When snow falls and it keeps falling and I want to simulate the accumulation, higher values in AJ1 is going to be an input value for the shader. So we'll simulate snow accumulation based on AJ. The snowfall, however, this is scary part. This is where I feel uneasy. And I'm going to tell you why. It is mostly correct. I like it. I think I might have to pull my threshold up to 88. And I'm kind of saying that based on this, even though I'm not going to use it, but this has some meaning. It's open to interpretation. I'm gonna stretch my legs a bit. Come back, and I think I'm going to tackle this next battle. There is something very promising about this. We are not going to calculate AJ1 yet, but we are either going to fine tune so that some of these truths are pushed to the false zone, or if they have to be true, we still need to calculate values for this, and that may have to be done in light of this part. So this is going to be used by itself, but it will play a role in calculation of these values. What happens? Time to interpret more. So here's what I'm thinking. 0, basically, because this being 9 missing is 0, because this is missing, whatever, right? Well, 3 is trace. Here's, I think, what's happening. The fact that we see 1 here. Remember, this 1 in terms of units is centimeter. And let's look at the temperature from positive to negative. We do see it's condensation on the ground. It is turning into ice, because this is not just snow accumulation, this is snow and ice on the ground. Since it's not snowing, it's not marked, and our value is, well, value system is saying it should be false, and it is actually correct here. These are the edge cases, right? We need to find a way to push this towards the false realm. Then this is going to be pretty much false, but this is going to be interpreted as well. Whatever humidity or whatever condensation there is on the ground. Let's not forget that during those hours it's actually raining. This is rain, and it froze. So this this and these two will be interpreted all together as it's raining and it's below 0 because it's been raining here. That's kind of what we get. And it's freezing. And actually, it's not always raining because it's 0.6. The second field here is 0 here, so this is in the past 6 hours. There's 0 centimeter of. I think this is in this case millimeter, but anyway, 0 rain amount. Here we have 10 millimeters of rain, and in fact below 0, it is going to be marked as frozen. We should just push these values false. This is the problem one. This is such a high number, is 92. It's kind of easy to push these to false because you could just say 85. You could push the 85 to 88. However, yeah, this is why I was introducing that duration thing. However, the drop was really high. Since this is such an exception, there a meaningful way it's below 0. It's raining. And these two are so close to each other. Yeah, in my mind, it's supposed to snow. So this makes sense. This is missing. And this is too far away from these two. But if we consider this, I'm going to make a blanket statement right now. I'll push it as high up as 93. Here. And I'm kind of confident this system is working as far as functionality goes. So here we go. False. False, 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 false. Look. False. Yeah, I see. So yeah, I'm looking at the line here, and yeah, so besides these rounded numbers, it's actually still false. I haven't missed a case. False. This is where I expect to see it true. This is 1 centimeter of snow in the past 6 hours. It isn't much, but it's something. This is 2 centimeters of snow, even a bigger case. So that's why I was putting 85. So it's much more likely that it snowed in here. Didn't snow. Did snow. And also when we say 6, this is where we measured it, but it was also snowing here too. Perfect. From this point's perspective, the previous 6 hours here No snow, no snow, no snow, no. And only in here, so maybe half a centimeter. Then we mark the measurement here, but it's also snowing, which is going to be marked here. So the 90% is a weird case. Now, let's change it back to 85. By do this. I'm also going to do this. Not that. Home data. Text to columns. This one. Comma. Yeah. Actually, I don't. Good question. Also, so this is where we'll this should not happen. This is the freaky case. Let me go down. If I do 87, it's going to get rid of this. Maybe then I'll ignore this. "2010 might be a weird year. 2008 was a much more eventful. Let's investigate this. Remove redundancies. Done. Remove FM16. Done. Please top row. Temperature split. View split. Get rid of this. Get rid of this. Calculate RH. Done. AL1. Split to bits. This is where it is getting interesting because of this measurement pattern. It's either 24 hours or 6 hours or some other number. Divide. And then look here, there's 11 centimeters on the ground already. We definitely need to take this into account some way. Let's do this. What do you mean false? Oh, because this is just that. Okay. So based on the 3 centimeters snow in the last 6 hours. Assuming it did not snow in these 4 hours, we had 3 centimeters of snow in these 2 hours. That's what we should do. Interestingly enough, do you give me the count? 15 to 32, 17, it's 18 hours. This is sort of a weird one. Okay, but assuming this 3 is already in this 9, so here is the 24 hours. And so we are distributing 9 centimeters to only the true ones. And here's the case where there's rain, things start to freeze. Here's ice accumulation, here's snow. As I said, we'll have snow here. This is somewhat checking out in my mind. Now we have these fluke cases where it's too wet. Yeah, how it's distributed here has nothing to do with the jump from 2 to 5 based on this 3. Let me think about that too. From 3 to 9, we should have 6. So 5, 6, 11. So that kind of checks out too. Then 24 hours, 0 snow. Hence, this 11 is sort of kept and not marked here. I'm not surprised because they are a little bit lazy. So here's 11 zeros. This definitely looks sort of shifted. Okay. So here's the interpretation actually. This is a good case too. I was going to talk about this. Now is the right time. So the 11 centimeters of snow on the ground. The temperatures are finally going over 0. I mean, there's evaporation at any degree anyway, but there's faster evaporation when the temperature is over 0, and it's actually melting. You can see. That's what this is about. This is going to be the shader work. It's eventually melting. And here, as I was saying, they are lazy. They don't mark it as 0, but we come from 1 to 0. So we'll interpret all this as 0. And in all this is false, which is good. It's not snowing. So here's what we'll do, I think. Even when we find cases where it says true, for whatever reason, whether it's below 0 or over 0, but for probability's sake, there's snowfall. Just because it's falling doesn't mean it's accumulating. Sometimes it melts, surface is so wet, it blends in, that kind of thing. And in those cases, I'm thinking we'll just show it as it's snowing and it's sort of fluffy. And I think it might be the case when the temperatures are, let's go to this. Let me actually look at those 92% sort of weird true cases or disk cases. Okay. This is a -4 case since I cannot really see that here. So let's look at this over 0 cases. Let's add this here. Let's do text columns. Done. I'm looking for true. And again, this is just borderline, but I'm also looking for true cases where this is over 0. True. And we had cases like that in 2010. We'll switch back to 2010 and true. Okay. Day 14 is the positive, right? Day 14. There. Yeah. False, false, false. Okay, I'm confused, and this is because, as I keep saying, this graph is dumb. It made me think that the temperatures were rising because going to right, it's rising. It's actually dropping according to the graph, but when you make a graph going along this axis, you're supposed to see things increasing, not decreasing. So I'm gonna have to look for the same thing under a different condition. So I'm looking for snowfall, not accumulation, and I'm expecting to find this condition. Or this condition. Most likely this. Let me think. I don't remember which one of these has more likelihood to accumulate. Let's go back to 2008, all the way to the beginning. We expect it to snow. It does snow. It's in some minus. Is it accumulating? It is accumulating. At -1 temperature, humidity is around 88, 90, which is this. So dendrites, it's accumulating. We assume this is dendrites all the way. Coming down. -2, even worst case. We need to look for cases where it's true, and -3 is the threshold. Let's see. I'm also going to keep an eye on this accumulation part. When this was 0, that's when I was saying it's melting. Here's melting. I need to be looking for trues from this point on, where there is snowfall but no accumulation, and I'm going to chalk it up to, this is kind of 7 degrees above 0 anyway, so it's unlikely. However, I'm going to look for a case where true. Okay, just there. Yeah, so dendrites, yeah, it is correct. I'm making that sweet spot 87%. I'm seeing a lot of accumulation around that number, and we have these weird cases. Mark it 87. The funny thing is actually this. It doesn't actually make sense here. It says in the last 24 hours, 2 centimeters snow. So then it all snowed here in 1 hour. It might. None of it has been accumulated. It's as if we had more true here, a few more, would have made a bit more sense. So if I pull the 85 to 84, would it take one of these cases here? It still wouldn't, because this would be over 0. You know, maybe I shouldn't have the strict 0. Sorry, I should have strict 0 instead of equal 0, which would push all these cases to true as well. That's what's going to happen. This is probably what's supposed to happen. And then this 85 might be fine, which is still questionable, but run this. So only I could remember which line was it? Well, either way, I'll see falses and then suddenly trues here. Yeah. This is fine. Okay, let's go back to our original file. Let's do a kind of assumption here. Clean slate. I don't need to find stuff. Do I want to separate you? Let's separate you. Do text to... Nope, it's under data. So this false is now pushed to true. Do we want that? Because I'm treating this as even though there's no data, according to my logic, it should snow here. By the same logic, it should snow here too, which no, let's not mess with this. This is fine. This is gonna be all put to false again, so what are we doing here? This data, text to columns. So let's finish. Oh, these were true anyway. For what reason? By the way, I thought I was in January range here. I just noticed I'm in December. So my familiarity with the data set is kind of skewed right now. So well, I'm gonna have to sign up in 15 minutes. I'm also feeling tired. Perhaps it's showing up. But I'm trying to make some decisions, but I'm kind of undoing some of those decisions. This is false. Yeah, that's what I was afraid of. All of a sudden, somewhere like this, I start to see true values, and I thought it was January. Then looking here, it actually checked out. Let's go and look at those values. Yeah, these are minuses, and it's close enough. That checks out. This is not checking out. That's the unfortunate part. And we will here assume that it's snowing but not collecting because it's also this. That's what we are trying to think. And the fine tuning here is whether this is actually strict zero or equality check. So when will that show? It will show here. Maybe it will push this to true. And even if it pushed this to true, we'll recover because it will look like it's snowing but not accumulating because we are safe here. That's what I was trying to check, right? For cases like this will most likely be... Will this be true? Let me think. This is still going to be false because this is not enough. This will still be false. Let me check other zero cases here. Day 14 approaching. This will fail. It will fail. Will fail, which is good. I think we could do this. I'll be cautious though. Okay, so let's do some recap and then I will get the notification that I think LinkedIn finally bailed out. Or not. They're still going strong on LinkedIn, but or not. No, this is the previous recording. So at some point at 4 hours, I guess it capped. It's okay. It's time to wrap things up anyway. So today's stream goals and this is kind of an ongoing process, but we did expose some more methods to the ribbon. We haven't started filling in the data, but we have made a lot of progress in determining how to fill the data in. For example, since we now have false values here and we have missing data, we will say, well, there is actually no snow because the possibility is snow. And in the likelihood that there is actually snow, like this, we will trigger the snow visually. But as far as accumulation goes, the shader will not trigger the accumulation part, right? It's not going to show that much on the ground. Actually, in this case, we will show it because of this, but we are determining that part still. This whole exercise is so that when you have a lot of missing parts like this, whereas like say it's 4 days in January and they only marked it here. Instead of marking this 0, they haven't actually written down anything. So it's now about distributing some of this. And in this case, we are checking that 85, 86, 87 thing, and this is the threshold thing, because if it was marked as snow, like this is the value of snow, and in here 85 is really the only possibility where it could have snowed, so that's why there's still a little bit of room for improvement there. So I'm thinking next time what will happen is, I don't know when next time will be, but I know what will be next time is whether we keep this here or not, but we need to fill in these two or either one of these based on the trueness value, the truthy value here. So if it's true, we'll have to look for some close enough value. In this case, it's sort of weird. This is really one of those edge cases. Maybe we won't have a fill-in function like we have here. So many of these functions or buttons are responsible for calculating the whole column minus the header. We may not be able to do that here because I was hoping that this would be false too. Then we would actually have true values accumulated here close enough to this. That doesn't seem to be the case anymore. We can actually try harder to make that case, but I really don't know what those conditions are supposed to be. So yeah, we'll probably, let me run this one more time and I will conclude it because this is now going to turn into true. Those two other true, those are the fluke ones, they will still be in there, right? So let's run this again. Yeah, like these ones, right? Yeah, I either have to fine tune this so that I push these cases to false, or I assume it's true and I come up with some silly values here. And I was hoping those values would be somewhere here, these being more true than false. And I think there is something about that exaggeration factor that I was working on, which still kind of makes sense because there's something appealing about that. Because when it's just over 85, it's 86, right? And the temperatures are okay below freezing. There's a difference between 95% saturation, 90% saturation, and just 86, just like 1% over the threshold, right? So it's as if, yes, there is a probability of snow here, but it's not that high of a probability. 90-95% is much more likely. So this is sort of very hard threshold here. Just because over 85 we say okay, true, but maybe it really shouldn't be because it's mostly false here. And based on the ground, like the accumulation on the ground, which is 0, we should really interpret this as false. So at that point we have two choices. That's what I will investigate next. I will either make this false, or just because this is true, when I'm supposed to type a value, I'm going to make a decision based on this, and I'm going to say, well, we kind of thought it was supposed to snow, but whether it snowed, it didn't accumulate, consider it not snowing, that kind of thing. Although, visually speaking, sometimes we should have snow, but not accumulating. Maybe that's a subcase, that maybe this is going to be higher enough, still snowing, and there's going to be 0 part here, so we'll show snow, but no accumulation. So that will have to be next time. And that next time might very well be next Wednesday. So that's it. And have a wonderful evening or morning if you are already in other parts of the world where it's morning for you. So have a good one.